Hello everyone, myself today we'll be learning about probability distributions and data analysis. As you all know, probability is nothing but how many chances an event occurs. Suppose if we flip a coin, the probability of getting heads is 50%. That is, there are two possible chances and getting one chance is half of it. That is 50%. So let me start with the first slide. Introduction to probability distributions. Definition and importance. Probability distributions describe how the values of a random variable are distributed. They are crucial in understanding data patterns and making predictions. So it is important to find the data patterns from the data set which we have collected, like what will be the probability of getting the same output, and role in data analysis. The role of probability distribution in data analysis is developing a real world model or developing and decision-making machine using the dataset which we have collected earlier. This helps in data analysis. Also, the overview of types is probability distributions can be discrete or continuous, each with different characteristics and applications. Discrete is like for one value, we get this many chances of the output or the percentage. Continuous is it will be varying based on the number of tries or trials you put. Discrete probability distributions. The example which we can take as the best example is rolling a die. This is like once when we roll the die, we get only one output. So it is considered as discrete probability distributions. And also flipping a coin can be considered for discrete probability distribution. Common discrete distributions include binomial and Poisson distribution, which model number of successes in a series of trials and number of events in a fixed interval, respectively. The Poisson distribution follows fixed interval of number of events, and binomial distributions use number of successes in a series of trials. Applications in engineering used in quality control, reliability engineering, and other fields to model defects, failures, and other accountable phenomena. Binomial distribution. A binomial distribution models the number of successes in a fixed number of independent Bernoulli trials. The formula is as stated in the slide, and the properties and assumptions are each trial is independent. That is, it is not dependent on the previous trial. Like we may get the same output or we may get a different output. With a constant probability of success, the distribution is characterized by n and P is the probability of success. Engineering use cases of binomial distribution is used in quality control, like to find the defective items in the manufacturing plant or reliability testing, testing the manufactured devices like the electronic components and finding the system failures which have occurred in the device. The Poisson distribution. Definition and formula. The Poisson distribution models the number of events occurring in a fixed interval of time or space. Like it occurs only for the fixed interval of time, and the assumptions are events occur independently with a constant average rate. Like after a certain interval of time, it occurs again automatically. And the lambda defines the mean and variance of the event occurring, and its engineering use cases are used in telecommunications for receiving the calls and reliability engineering for to check the failure rates and traffic flow analysis. Continuous probability distributions. Continuous probability distributions make scenarios where outcomes can take any value within a range, such as measurement of time or temperature. Like time is continuous, it will be changing. After each seconds, the clock will be ticking and the hand rotates. So it is example of continuous probability distributions. So common continuous probability distributions are normal and exponential distributions, which model phenomena like natural variations and time between events. It is mainly focused for time between events, and it is used in signal processing, quality control, reliability analysis to model continuous data and optimize processes. Normal distribution. It defines as or it is also called as Gaussian distribution, as a continuous probability distribution characterized by a symmetric, bell-shaped curve graph. Like the graph will be formed like a bell-shaped graph. Also, the properties are it for uses mean, standard deviation. The distribution is symmetric around the mean. The most data points falling within three standard deviations. The common engineering use cases are using quality control, finance, and natural sciences. Exponential distribution. An exponential distribution model is the time between events in a Paulson process. The formula is as stated, and also the properties and assumptions are numerical property with a constant hazard rate. Like the value will be changing continuously and it is not stored. Engineering use cases is for to find the failure of the components, also arrival of two events or occurring of two events. Central limit theorem. The central limit theorem states the distribution of the sum of a large number of independent, identically distributed variables approaches a normal distribution regardless of the Weisner distribution. And implications for data analysis. CLT allows for making inferences about population parameters using simple statistics. Visualization of CLT in practice. CLT can be visualized by plotting the distribution of sample means from different samples of the same population, showing convergence to a normal distribution. Probability distribution fitting, like finding a theoretical distribution that closely matches the empirical data. Techniques include maximum likelihood estimation method and moments. Goodness of fit tests. Statistical tests such as the chi-square, Kolmogorov-Smirnov, and Anderson-Darling tests are used to assess how well the chosen distribution fits the data. Practical applications in engineering is used in reliability analysis, quality control, and risk assessment to model and predict various engineering phenomena. Visualizing the probability distributions, like there are several methods which I have explained to find the probability, and they can be visualized for easy understanding using the techniques, and it is main part to understand the probability using a graph so that it is easy to understand. So what we learned was probability distributions, its types, and how different types of distributions work, and how it is used in engineering. Also, we can refer a few textbooks to understand them in detail. Like I mentioned, the recommended resources for further study. Thanks for watching. Please like the video.